Software developers are big damn heroes. We work with the most complicated systems on the planet. They adapt dynamically, not only inside the code, but to their environment. As customers do unexpected things, they respond somehow. And as we build more and more systems of systems, we get more and more adaptive behavior. We have self-healing systems. We have all sorts of things going on there, which is wonderful until we need to change it, which that gets back to our heroism. See, a complex adaptive system is designed to respond to its environment. When any one part of it notices a difference, it just changes. And then that changes the environment and other parts respond accordingly. But when we want to make a change in a business sense, we don't actually want that. We don't want a system that grows arbitrarily in the direction that it wants to grow. We want a system that grows in accordance with our business desires. And that's the heroism of software development. Cheers to us. We are the ones who manage change. It is our job to identify what should change, what is not allowed to change, and what needs to change, and cause the system to grow and modify in that way, much like a gardener does. In order to work with that for software, the problem is that, of course, software is invisible. So we use tests of varying kinds in order to see whether they're manual tests or automated tests or monitoring or whatever. They're all different ways to probe and understand what's going on in the system. Now, because our systems are complex adaptive systems, these tests are by necessity whole system tests. After all, one of the features of a complex adaptive system is that if you break it into two pieces, it no longer behaves the same way. If you take a human body and you break it into pieces, it doesn't have human body behavior, right? And in fact, each subsystem no longer behaves the same way. So you can't really see what's going on for the system as a whole by looking at the parts. You have to look at the system as a whole, which is problematic because whole system tests are complicated and fragile and slow, and you can only check one portion at a time because the whole system has all these dynamic behaviors and so on. So what if, here's the proposal, crazy proposal, what if instead of a complex adaptive system, we had complicated but deterministic and decomposable systems? Now, this has some advantages and some disadvantages. First, the biggest disadvantage is that it loses self-adaptability, right? You can't have a self-annealing system if it's only complicated, because that is a complex adaptive behavior, right? But it gains some abilities too. One of the biggest gains is that it's easier to change from the outside. And we as humans are outside of that piece of software. So as a developer or as a business, we can now direct the software to change in the way that we want it to change. That becomes easier. We can test it. We can verify also that a piece is behaving as we would like, because these systems are decomposable. When you take one chunk out, it still behaves the same way, so you can verify it in isolation. Right? Great, wonderful. The challenge is, how do you get from here to there, and how do you maintain some of those features that you do want, like self-annealing, in an environment where the system doesn't create them by itself, right? And really can't directly create them. So how do you create this system that is halfway between those two? Often you do want a system that is mostly going to change the way you want, but also to start responding in reasonably sensible ways to unexpected stuff. So Deeproots exists to show you how to create those gray boundary-like systems and how to get your system from the complex adaptive space to one where most of it is deterministic, and get there incrementally without breaking or losing those capabilities that you need along the way. We've got some of those in this newsletter. And in fact, there's a bunch of articles on our site for very specific cases of how you'll do that. And if you want something a little more interactive, we've got a Legacy Code Whiskey Hour coming up. Now we're just going to sit around, drink some whiskey, chat about Legacy Code, and have a good old time. And for something a little more formal, my friend David Bernstein is running some CSD classes. He gets into patterns and refactoring to patterns, so that might be another good thing to check out. I'll insert links to both of those in the newsletter down below here. So read on, and I hope that you find this useful as you change your system to make it easier to change.